Morgenstern again with Lab 9, Conservation of Linear Momentum Collisions. My favorite lab. We're going to break some stuff today. So, we're going to go over the physics first. What is momentum? We write it as P, and notice it has a little arrow. It's a vector. It's not just a number. It has a magnitude and direction. And we can write it as M, the mass of our object, and then V, the velocity with vector, so with direction. So then we have momentum conservation like energy conservation. If we have two objects, then in the beginning they have an initial momentum, object 1, object 2, and then after they collide or crash together, they'll have final momentums of each object. And the initial momentum, if we add up all the pieces, should be the same as the final momentum if we add up all the pieces. And we can make this like energy and make it a scalar. So what we can do is, if you notice, there's a vector, so there's 3 dimensions, x, y, and z. So we can actually write this out a little further and say P1 initial x plus P2 initial x equals P1 final x plus P2 final x. And now each of these is just a number, which is the spatial component x of the full momentum. So this is essentially 3 separate equations, one for x, one for y, one for z. So in what we're doing today, we'll only have one dimension because we're on the air track, so we're confining the carts to be in the x direction. So now we can look at what are the types of collisions. There's 2. There's elastic and inelastic collisions. In an elastic collision, we will conserve momentum and kinetic energy. So the carts will ram into each other and then bounce off each other. And then inelastic, we will conserve momentum, but we will not conserve kinetic energy. So this is when the carts ram into each other and stick together. So you may be thinking we have conservation of energy. Nope, this is just kinetic energy. So we can think about the kinetic energy will change, but energy is conserved, so it will be converted into potential energy. And we'll look at that more when we do the example. So in this lab, we'll have 2 carts. We'll weigh both of the carts. And then we have 6 different cases we want to look at with 2 trials per case for a total of 12. So I've listed the 6 cases here. We will have cart B at rest in between our photo gates, and then we will send A in to ram into B. And both carts will have the same mass. Then in case 2, we will send B off at a slow rate and then send A faster to crash into B. And again, the carts will have the same mass. And then case 3, A will be moving and then B will be at rest, but B will be heavier. I'll add extra weight to B. And then 4, A's moving, B's at rest, they have the same mass. So 4, 5, and 6 are the same as 1, 2, and 3. But the difference is in cases 1 through 3, we'll have elastic collisions with rubber bands and bumpers. In cases 4 through 6, I will use a needle and clay so that they stick together and it will be inelastic. Then for our report, we'll answer questions like always. We have one super chart that has the initial velocities, masses, everything, momentum, so you'll fill that out. And then we don't have any graphs, but we have before and after pictures. 12 total, a before and after for each case in 6 cases. So I've gone ahead and I've done the first case for you right here. So in case 1, remember back, A's moving, B's at rest, they're the same mass. So before, I have my 2 photo gates. I have B in between them at rest, so its velocity is 0. And then I send in A to ram into B with some initial velocity. So this is before. Then after the collision, we have our 2 photo gates again. We'll find that cart A, its velocity is 0, its final velocity. In cart B, we'll have some velocity B final as it moves off. So let's actually do this and see the results over here. So again, I had started by weighing all the carts with each component on, and I have these heavy metal cylinders that I add to make the carts heavier. They go on the side. So what I'll do, I'll turn this on, and I want to put it onto speed collisions, and then we'll look at case 1, where I'll put cart B in between cart A here. Let me turn on the compressor. So we have our carts. I'll hold this one steady. I'm going to send this guy through. And then we're going to get, my mistake. Sometimes accidents happen. Let's do it again. There we are. So now we can see photo gate 1, cart A had an initial velocity of 82.6 centimeters per second. And then at gate 2, cart B had a final velocity of 69.9 centimeters per second. So this was case 1. So now in case 2, how that works is I'll start both carts over here. I'll send cart B through slowly, let it get through the gate, and send A through quickly. And then I'll let them go through both gates, and I'll get the data. And then case 3, I add my little extra weights on to cart B. Then like case 1, I'll have them sit here, and then I will send this guy through. Now something to notice about this case is cart A went backwards, so since velocity has a direction, that will actually be a negative value. And on the Excel sheet, you'll see I've recorded them as negative. Those were cases 1 through 3. So now case 4, 5, and 6, I replaced the bumper and the rubber band with a needle and clay. You gotta be careful with the needle. They've been here a long time. You don't want to get some horrid disease, so don't prick yourself with it. So again, case 4 is like case 1. At rest, I send this through. They stick together. They have the same speed going through cart B. Then case 5 is like case 2. I send one through, B through slowly, and then A through quickly. They'll stick together. And then the final case, case 6, I add my little extra masses again. Then I send cart A through, they'll stick together, and we'll measure them at cart B. So, those are all the cases, and you'll find the data on Canvas. So, thank you for your time again, and I will see you in Lab 10.